All right, we're going to take a look at elimination method. So far to solve linear systems, we've taken a look at solving them by graphing, identifying the point of intersection, and then solving by substitution. So we're going to be referring to the blue sheet you've received in class. And the first problem we're going to take a look at is the linear system, 4x plus 8y equals 20, and then negative 4x plus 2y equals negative 30. So let's take a look at our first step. So our first step for the elimination method is to multiply one or both of the equation by a constant, a number, to obtain coefficients that differ only in sign for one of the variables. So we want either the variables or the coefficients for the x variable or for the y variable to be the same but different sign. So if one's positive 4, we want one to be negative 4. If one's negative 10, we want the other to be positive 10. Now if we take a look at our first example, we'll notice the coefficients of x are already the same but different only by sign. We have positive 4 and negative 4. So for this particular problem, the first step has already been completed for us, so we can move on to the second step. Our second step was to add the revised equations from step 1 and solve for the remaining variable. When you're doing the elimination method, you're always going to be adding the linear expressions together. So we're going to add this together. 4x plus negative 4x is 0. It cancels out. It's eliminated, hence the term elimination method. 8y plus 2y gives us 10y. And that equals 10 plus negative 30, which will be negative 10. All right, so we're solving for y. So we have a one-step linear equation here. We'll divide both sides by 10. So y equals negative 1. So that's our second step. Our third step, we're told, once again for a new blue sheet, to substitute the value obtained in step 2, so y equals negative 1, into either of the original equations and solve for the other variable. So we can substitute it into either of the original equations. It's going to work for both of them. I'm just going to do the first one. Once again, if you chose the second one, you'd still get the same answer. So we have negative, so good. We have negative 4x plus 2. Once again, when we substitute values, use parentheses. 2 times negative 1 equals negative 30. Now we're solving. So we have negative 4x minus 2 equals negative 30. We have a two-step linear equation to solve here, so keep in mind the skills, we just build on them throughout your mathematics career. Doesn't go away. So we'll add 2 to both sides. So we'll get negative 4x equals negative 28. Then we'll divide both sides by negative 4, so we get x equals positive 7. Once again, though, since we're solving, we have to express our solution as an ordered pair, as x comma y. So we have to express our solution as 7 comma negative 1. And one great thing to keep in mind with solving linear systems, you can check it. Substitute 7 back in for x, y back in for negative 1, and you should get, for each equation, for the first one, 20, and the second one, negative 30. All right, for a second linear system, we're going to take a look at negative 4x plus 9y equals 9, and then x minus 3y equals negative 6. All right, once again, referring to the blue sheet, our first step, we multiply one or both of the equations by a constant, keep in mind that's a number, to obtain coefficients that differ only in sign for one of the variables. Now, unlike our first example, this example, both of our coefficients, none of them are the same, that differ only by signs. Our x variables, we have the coefficients negative 4 and 1. Our y variables, we have the coefficients 9 and negative 3. So there are a few different approaches you can take here. Once again, just like with substitution, there's no wrong way or no wrong variable to solve for. We just have some strategies we can use to produce smaller numbers and therefore maybe make it a little bit quicker to solve. So there's no wrong approach here. You can get in the habit of always canceling out the x variables or the habit of always canceling out the y variables. It doesn't necessarily matter. One trick you can use is you can find the least common multiple for both of your coefficients. So the least common multiple of 4 and 1, keep in mind multiples of 4 are 4, 8, 12, 16, 20. Multiples of 1 are 1, 2, 3, 4, 5, 6. So the least common multiple of our x variables are 4, and the least common multiple of 3 and 9 is 9. Now, the purpose of identifying the least common multiple is that's what you're going to need to multiply by the smallest number. So I'm going to choose to eliminate the x variable since its least common multiple is 4, which is less than 9. So since I've chose to eliminate the x variables, I want my coefficients to be both positive 4 and negative 4. Now, the variable of x, or the coefficient of x in the first equation, is already negative 4. But I need to ask myself, what do I multiply 1 by to get 4? And that's going to be 4. So I'm going to be multiplying this bottom equation by 4. Once again, I want my coefficients to be 4, but keep in mind we need the coefficients to differ only in sign. So we need a coefficient that's positive 4 and a coefficient that's negative 4. And since the first equation already has a coefficient of negative 4, I don't need to multiply that equation by anything. But my second equation has a coefficient of 1, and 1 times 4 will give me that coefficient of 4. But once again, to balance that entire equation, you have to multiply both sides by that constant. All right, so I'm going to rewrite this first equation. So we have negative 4x plus 9y equals 9, and then distribute out the 4. So we get 4x minus 12y equals negative 24. And now we're going to add those revised equations together. And just like our first example, negative 4x plus 4x is 0. The x variable is eliminated. And then we have 9y plus negative 12y, which gives us negative 3y. And that equals 9 plus negative 12, which is negative 15. Then we divide both sides by negative 3, so y equals positive 5. Keep in mind a negative divided by negative is positive. And be careful with your signs here, because a little mistake here will mess up our x, the value that we get for x as well. So be cautious with those. All right, our third step, once again, we substitute the value obtained from step 2, so y equals 5, into either of the original equations and solve for the other variable. So I'm going to substitute it into the original of the second equation. So we have x minus 3 times 5 equals negative 6. So this gives us x minus 15 equals negative 6. So I'm going to add 15 to both sides. So we'll get x equals positive 9. Once again, we express our solution as an ordered pair as x comma y. So our solution will be 9 comma 5. All right, the third example we're going to take a look at is a linear system 2x plus 8y equals 6, and then negative 5x minus 20y equals negative 15. So our first step here, once again, we're going to multiply one or both of the equations by a constant to obtain coefficients that differ only in sign for one of the variables. All right, here we notice none of our coefficients are the same, but differ only by sign. So we're going to need to multiply one or both of the equations. So let's look at our least common multiples. All right, our least common multiple of 2 and 5 is 10, and the least common multiple of 8 and 20 is 40. So we're going to choose to eliminate the x variable since it has a smaller least common multiple. So we need to make our coefficients positive 10 and negative 10. Now if we look at our coefficients, one's already negative and one's already positive. So we're going to be multiplying by a positive constant for both of these to keep that negative coefficient of our second equation. All right, so I can obtain positive 10 by multiplying 2x by 5. But once again, to balance the equation, we multiply both sides by 5. So that is going to equal 10x plus 40y equals 30. Now, to obtain negative 10 in the second equation, I'll multiply negative 5x by 2. And keep in mind, multiply both sides by that value. So that will give us negative 10x minus 40y equals negative 30. All right, So that's our first step, and we're rewriting those in our second step. And keep in mind, to eliminate, we're going to add these expressions together. All right, so we get 10x plus negative 10x, cancels out at 0. Then 40y plus negative 40y, which is also 0. And then 30 plus negative 30, which is 0 as well. So we're left with 0 equals 0. Now we have to think about how often that's true, and that's always true. So since it's always true, we have infinitely many solutions. And that is our answer.